Welcome back, mathematicians. In this video, we are going to learn about the sum and difference formulas for cosine. So these two formulas allow us to evaluate cosine for angles that are not necessarily what I would consider quote-unquote common. So in other words, they're not multiples of 45 degrees or multiples of 30 degrees. So we have cosine of alpha plus beta, which is equal to the cosine of angle alpha times the cosine of angle beta minus the sine of angle alpha times sine of angle beta. Likewise, we have a difference formula which says cosine of angle alpha minus beta, so the difference of these two angles is equal to the cosine of angle alpha times the cosine of angle beta plus sine of angle alpha times sine of angle beta. Let's now use this to find the exact value of a specific example, so cosine is 7 pi over 12. Our goal is to break up 7 pi over 12 so that we can rewrite it in terms of two angles which are known to us where we can evaluate exactly cosine and sine. So in other words, maybe say a multiple of pi over 4, a multiple of pi over 3, or a multiple of pi over 6. So I'm going to rewrite 7 pi over 12 into the sum of 3 pi over 12 and 4 pi over 12. I choose these because when I reduce, I get pi over 4 plus pi over 3. And I know what the exact value is of cosine and sine of pi over 4 and pi over 3. So now I can rewrite cosine of 7 pi over 12 as cosine of pi over 4 plus pi over 3, and this will be equal to, according to my sum formula, cosine of pi over 4 times cosine of pi over 3 minus sine of pi over 4 times sine of pi over 3. I can now evaluate each of the trigonometric functions for their respective angles. So I can replace cosine of pi over 4 with square root of 2 over 2. Cosine of pi over 3 is equal to 1/2. Sine of pi over 4 is equal to square root of 2 over 2. And sine of pi over 3 is equal to square root of 3 over 2. I can now find the product. So I get square root of 2 over 4 minus square root of 6 over 4. And if I'd like to, I could rewrite this as a common denominator. So it would be square root of 2 minus square root of 6 all over 4. I can also use the formulas to reverse the process. So given cosine of 70 degrees times cosine of 25 degrees plus sine of 70 degrees times sine of 25 degrees, I can recognize, does this match the pattern for a difference formula or sum formula for cosine? And the answer is yes. It actually matches the difference formula for cosine. So this is equal to the cosine of 70 degrees minus 25 degrees. So it matches that pattern. I know then the difference between 70 degrees and 25 degrees is 45 degrees. And so cosine of 45 degrees is equal to square root of 2 over 2. So now the exact value of cosine of 70 degrees times cosine of 25 degrees plus sine of 70 degrees times sine of 25 degrees is actually equal to the exact value of square root of 2 over 2. All right, guys, good luck.